Okay, I'm going to go ahead and get started. Hello, everyone. My name is Kelly Dudley, and I'm with the New Center. And today I'd like to welcome you to today's webinar entitled CarbiCrete, Making Concrete a Climate Solution. And we're so glad you could join us today. A video recording and PDF of the presentation you're about to see will be uploaded to the new website shortly at newconcrete.org following today's webinar. Questions can be asked in the Q&A dialog box in the Zoom platform. It will be answered once the presentation is completed. Attendees are only in listen mode. Okay, quick disclaimer. The ideas expressed in the following presentation are those of the speaker and do not necessarily reflect the views of the New Center ACI or its committees. As with all concrete mixtures, trial batches should be performed to verify concrete properties. Results may vary due to a variety of circumstances, including temperature and mixed components, among other things. You should consult your materials, cement, and concrete professionals for design assistance. Nothing contained herein shall be considered or construed as a warranty or guarantee, either expressed or implied, including any warranty of fitness for a particular purpose. Okay, we'd like to just take a few moments to have some questions for you. I'm going to go ahead and launch the poll. If you could just take a few moments and answer the questions, I would appreciate it. Okay, I'm going to go ahead and read the results. It looks like approximately 83% of you answered yes to the first question, which is, do you believe that there is a willingness in the market to pay a premium for low carbon concrete? And 83% said yes. The second question, do you expect projects you are involved with in 2025 and 26 to require the use of low carbon concrete materials? Again, high number, 73% said yes. And finally, do you think the market will prefer low carbon concrete solutions that have obtained validation or verification of environmental claims? Okay, and this one is a landslide. 100% of you said yes. Okay, thank you so much. We appreciate your feedback. Okay, now I'd like to introduce their speaker, Jacob Homiller. Jacob is the CEO of CarbiCrete, a leading company in the decarbonization of concrete. CarbiCrete's patented process for making decarbonized concrete eliminates cement-related emissions and removes carbon dioxide from the atmosphere by replacing cement with a steelmaking byproduct and mineralizing CO2 into the concrete for permanent storage. Prior to CarbiCrete, he was the president and CEO of HC Stark Solutions, which is a leading global manufacturer of technology metals used in a broad range of industries such as electronics, medical devices, and aerospace. Prior to that, he was with HC Stark Solutions, served in the senior global leadership role with A.W. Chesterton Company and Cabot Corporation, as well as Bain & Company. Graduated from Tufts University with a BA in economics, earned his MBA from the Wharton School, and an MA in international studies from the University of Pennsylvania. Okay, go ahead, Jacob. Feel free to start your presentation. Thank you.
Great. Thanks for the introduction. Appreciate that. Welcome, everybody. Really excited to have a chance to talk with you about CarbiCrete and our technology. Really what we're trying to do is make concrete a climate solution. So CarbiCrete technology enables the production of cement-free concrete made with a steelmaking byproduct. And in that process, we capture CO2, permanently removing it from the atmosphere. And I think one of the things that really makes the CarbiCrete technology unique from other competing technologies out there is that we're 100% cement-free in the mix of making concrete, which is a really unique value proposition. Probably many people are aware, but cement is a global problem. Overall, concrete is a great product. It works really well in the different applications. It's cost-effective. It's the most consumed substance on Earth after water, and the demand for concrete continues to grow. The downside of concrete is cement, which is the binder in the concrete materials. The production of cement generates about 8% of global greenhouse gas emissions. And to put that into context, the global aviation industry generates about 2 to 2.5% of global greenhouse gas emissions. So it's a very significant polluter. The other challenge for the industry is that the cost of cement is high and has continued to increase well above inflation. The CarbiCrete solution, as I said, really solves that cement problem. And the way that we do that is we take steel slag, which is a waste product from the production of steel, typically using electric arc furnaces or basic oxygen furnaces. That material, steel slag, is often landfilled. Sometimes it has low value applications like road base in road construction. So we take that waste product from the steel industry, we grind that into a fine powder, very similar to Portland cement. And I think one of the great things about the CarbiCrete technology is that from there, the rest of the equipment we use until the very end of the process is very standard manufacturing equipment. So the mixing equipment, the block making machine, which you can see in the center picture, or paver making machines, the finger carts that move the materials within the facility, all of that is standard equipment that we use with our process. Really where the secret sauce or the magic happens is in the curing process. So a typical cement-based concrete product goes into a curing chamber. It's time, temperature, humidity, and the material comes out partially cured, and then typically it would sit in the yard for 28 days to reach full strength or full hardness. In our process, we use a similar chamber. Once the materials are loaded into the chamber, we shut the door, we fill the chamber with CO2, and then the CO2 mineralizes or chemically reacts with the materials that are in the steel slag to create the binder. And in that same kind of 24-hour curing time, the products come out 100% cured, so they've reached the full strength and hardness, and they're ready to go to a job site. So there's opportunities for working capital savings, but also space savings in the yard on a typical concrete products manufacturing site. So why steel slag? I think it's important to know, and probably many people are aware that granulated blast furnace slag, so iron slag, has been used in the cement and concrete industry for a very long time. We use, as I said before, steel slag that comes from electric arc furnaces. So it's fundamentally a different material than the GGBFS slag that maybe many people are familiar with. So we're finding a new purpose for that EAF steel slag. This is a material that's readily abundant. There are hundreds of thousands of tons at many steel manufacturing sites. There's over 350 million tons of steel slag generated each year. So finding an opportunity to use that in a value-added way is a great part of the overall CarbiCrete story. So carbonation curing. So this is what's happening when we introduce CO2 in the chamber with water and the steel slag that's part of the overall mix. During our process, the CO2 becomes a solid mineral, so it's reacting with the materials that are in the steel slag to create calcium carbonates or calcium silicate hydrates. And that's fundamentally what gives the strength to the CarbiCrete products. The CO2 that we use is biogenic CO2. Today, what we utilize in Canada is CO2 that's captured at ethanol plants, and then that's introduced into the chambers and then permanently sequestered into our materials. Things like direct air capture or industrial point capture of CO2 are really interesting opportunities. We've done a lot of work to validate that we can cure our products with lower concentration levels of CO2. So that opens the door for both cost savings in the future and reducing the cost of the CO2 input, but also being able to kind of improve the circularity, improve the ability to generate value for industrial waste streams of CO2, which are prevalent out in the market. So to give you a sense of the magnitude, so 1 CMU, a concrete masonry unit, which is kind of what you see there in the picture, in 1 CMU, we're avoiding 1.5 kilograms of CO2 emissions because we don't use cement. And then we're permanently sequestering about a half a kilo of CO2 into each of the blocks that you see on the page there during the curing process. So in total, we have about a 2 kilogram per CMU impact on CO2, both through reductions and removals of the CO2. To give you kind of a frame of reference, so we've gone through, we have a third party produced and ASTM validated EPD. But I think one of the key takeaways is if we look at the global warming potential of a CarbiCrete material, we generate about 11.7 kilograms of CO2 per cubic meter of concrete. When we compare that to the industry average in North America of 232, we're about 20 times lower in GWP than the industry average, which is really a significant impact on the CO2 attributes of concrete and make it, a much more impactful, low carbon building material for industry. One of the things that's really important when people are looking at projects as far as project developers or project owners is looking across the different building materials that can be used for different projects. And again, we're at 11.7 for a CarbiCrete CMU. You can see cement-based CMU about 232, ready-mix concrete of 278. Even when you compare to softwood lumber, which is often touted as being kind of a greener, low carbon footprint material, we're substantially below softwood lumber from a GWP standpoint. And then obviously you compare to steel as a construction material, it's dramatically higher in its CO2 impact in its production. As I said, we worked with Climate Earth as the validator of our life cycle assessment. So looking at all of the impacts of CO2 and a number of other factors. There was a lot of work that we did with Climate Earth, and then all of the work that Climate Earth did was validated by ASTM. So this one demonstrates that the impact that our products can have for project managers, along with lead points and things like that. It also gives us direction on things that we can do to further reduce the emissions footprint of our products, which is obviously something that's important to us and that we're working on from a development standpoint. Right now, we're commercializing our technology through licensing partners. So we have a licensee in Quebec that is producing products and selling those into the market here in Canada, but also into the northeast of the US. We have a licensee in Ontario where that project is being executed right now. We expect mechanical completion by the end of March and then commissioning and startup in April. So we're excited to be able to have products available for the Greater Toronto area. We have identified a joint venture partner in the southeast of the US to co-locate a facility at a steel mill. So we have optimized slag cost and logistics, as well as licensing partners in Europe and in the United States that we're working to finalize commercial terms and project execution. For licensees, we offer the opportunity to generate higher margins, both through potential price premiums for decarbonized building material, but also as an offset against increasing and high cement prices, but also the ability to differentiate their products for projects that have specifications for low carbon building materials. So the ability to gain market share and win new jobs. And then there's also the opportunity to generate additional revenue streams through carbon financing. We signed and announced late last year a multi-year offtake agreement with Meta for the avoidance credits that are generated from our projects in Quebec and Ontario. And then for end users of our products, it gives them the ability to meet their net zero targets, to generate lead points for LEED certified buildings, and to deliver much better environmental benefits while still delivering all of the technical performance that is demanded in CMUs and other concrete masonry products. Today, we're producing and have certified concrete masonry units, so we meet all of the performance expectations for compressive strength, freeze thaw, fire rating, etc. for CMUs. We're also our licensee customers are producing paving stones, grow-through pavers, deck blocks, so that kind of set of hardscape products. We continue to do development on some thicker materials like interlocking pavers and professional pavers, as well as colored pavers that we're producing here at our facilities in Montreal, and looking to introduce into the market with our production partners. Our first full-scale commercialization is with our partner Patio Drummond in Drummondville, Quebec. They are able to produce and supply products in Quebec as well as into the northeast of the U.S. They've been have had products available and have been selling those products since the early part of 2024. Our team does a really good job of working with them, meeting with architects, with engineers on a cooperative marketing program. And we continue to expand our pipeline of licensing opportunities with companies like Gagne & Sons in the US, as well as a number of other companies where we have MOUs in place for licensing our technology for future production. So those were the prepared kind of remarks and summary about CarbiCrete. Happy to answer any questions people have about the technology, the business, or other questions. So I'll kind of pause there and turn it back over to you for questions.
Great, thank you so much. We're going to go ahead and let you have a few minutes if you want to answer or put any questions into the Q&A. We do have a few already, but I'm going to go ahead and just give you some time to ask a few questions if you have some. Okay, it looks like the first one you may have already answered, but I'll just mention it. Is steel slag the same as blast furnace slag?
Yeah, I mean, that's a great question. We get it all the time. No, it's not the same. It's chemically different than blast furnace slag. So blast furnace slag, probably a lot of people are aware, is something that's been used as a supplementary cementatious material. It's blended in with traditional Portland cement for a variety of different cost and performance reasons, and it is it's reactive with water in that cement mix. Steel slag is different. So steel slag is reactive with CO2 in the presence of water, and that's really our technology is curing that steel slag using CO2 in the curing chamber. So it is a different material. It currently is not used in the concrete industry.
Okay, thanks, Jake. Okay, more questions are coming in. We have, do you need to cure the blocks at an elevated, oh, it's moving, hold on. Do you need to cure the blocks at an elevated temperature?
So in the chamber, the process controls and the technology that CarbiCrete has, there is an aspect of drying or reducing the moisture content in the material. So there is some level of heat used in the process, as well as the kind of the airflow requirements to make sure that we have full carbonation through the materials.
Okay. Thank you so much for your question. Are these products available in the US now?
Yes. So we have our customer in Quebec, Patio Drummond, is currently producing products and has sold those products into the US. So you can definitely reach out either to CarbiCrete or to Patio Drummond if there's interest for supply into the US. And then we have a number of companies that we're manufacturers that we're working with about licensing our technology for production in the US.
Okay, great. Okay, next, does the technology potentially apply or transfer to limestone production?
Yeah, that's a good question. I'm not the science expert within the company, but I would generally say, no, that's not something that we would expect it to be applicable. As far as kind of like limestone, kind of converting limestone into clinker for cement production, we wouldn't see that as working with our technology.
Okay, let's see. Can this technology be used in steel reinforced concrete products?
Yeah, I mean, if you mean kind of like with walls built with, with rebar inside, yes, absolutely. That's part of the testing that's been done. In building the wall for the fire test, or other elements of the testing that's required for evaluation and certification in Canada, which we've completed all of that testing. We're working on all of the, each jurisdiction has different test requirements, so we're working through that process in France with a strategic partner. We are underway on all of the testing in the U.S. as well for certification in the U.S. market as well.
Okay. Have you done any performance testing as compared to conventional ASTM C90 CMU?
Yes, absolutely. So, that's kind of the C90 standard is kind of the benchmark standard for looking at the, kind of the performance and technical validation of CMUs. And yes, we meet or exceed all of the requirements for ASTM C90.
Okay. Let's see. There's a few more coming in. Okay, that you mentioned that you cure them for 24 hours in the curing chamber. At what temperature and what strength are you looking for?
Yeah, I mean, when we create and work with our customers to create the formulation. When I think about formulation, I mean the percentage of slag, the percentage of aggregate, so sand and stone, as well as water, and if there's any admixtures. So that formulation is adjusted based on the performance characteristics that we're trying to achieve and the product itself. So, specifically related to, what strength that we're looking for, we're obviously trying to, meet or exceed the strength requirements. So the strength requirements for a retail paver in the marketplace are different than for a professional paver. So, our formulation may be adjusted, and the curing process and time may be adjusted to hit those different strength levels. But that's really part of the the technology and technology transfer package that we provide and work on with our customers.
Okay, thank you. Okay, let's see. Is this a solution that you see for precast, pre-stressed, ready mix, and/or volumetric concrete production in the future?
Yeah, so our technology is really focused around precast products. So ready mix, which is the ubiquitous trucks that you see that are spinning and are pouring slabs or different kind of poured concrete solutions. That's not an area of focus with our technology. I think the way to think about it is concrete products that are made in a manufacturing facility and finished in a manufacturing facility. So paving stones, any of those hardscape products, as well as CMUs, that's all very much applicable for our technology. We have patents around concrete pipe and the curing of concrete pipe. That's not a short-term focus of ours from a business development standpoint, but it's something where we have capability. But if you think about kind of the ready mix poured concrete from the rotating trucks, that's not where we're focused for the impact that we want to have on the market.
Okay, thank you. Can a producer partner share in the carbon credit revenue with CarbiCrete?
Yeah, so I mean, we have a team that's done a lot of work to develop partnerships with a company called 3 Degrees, which helps us to both market our carbon attributes, but also helps in the MRV process. And so we typically own the carbon credits in our relationship with our licensees, and then it's a commercial discussion around how we monetize those carbon credits and the value that's created through that. So that ends up being a commercial discussion with our partner or potential end users.
Mm-hmm. Okay, thanks for your question. Okay, it looks like we might have about, let's go over about 3 or 4 more, and then I think we'll wrap it up. It looks like, do you need to alter the chemistry of the steel slag before putting it through your process?
No, so the steel slag, comes off the steel, out of the steel facility. It's air cooled. Often there's, a steel services company that's doing metal separation, so they'll extract any residual metal there that's of value to the steel producer, and then that, we'll call it raw slag, would then kind of start into our process. So it would be ground into a fine powder and then comes into a manufacturing facility. There's no further processing or chemical treatment or reactions that need to take place or do take place.
Does the process need plant retrofit?
Yeah, so one of the things that I think is really great about our technology is that the vast majority of the traditional precast manufacturing equipment is the same. So we can use the same silo that cement goes in, the same conveying systems, same mixing, same block or paver machine, all the the logistics kind of so the finger carts that move the pallets of materials around. Really, the only retrofit is the curing chambers. So we need to have a curing chamber that we can seal, and then we have to have a CO2 delivery and piping system installed. Typically, if you're working with kind of the packaged gas companies like a Linde or a Praxair, they provide that equipment, and you just need to do the piping into the chambers. So most of the chambers that we've worked with so far have been purpose built for our process and installed on customer sites. There are opportunities to retrofit chambers that are already at a customer site and make them, CO2 and CarbiCrete technology capable.
Okay. What are the technical breakthroughs of the curing process in the next years? For example, lowering CO2 concentration requirement in curing, lower pressures, etc.
Yeah, so that's a good question. So first of all, I'd say, we do not require pressure in the chamber, which I think is really important from driving CapEx costs down and making implementations more and more affordable. That's been an important, that's an important development. That these are not pressurized chambers. It's really just a sealed chamber. And then, being able to utilize lower CO2 concentrations, we've demonstrated that at the lab and at pilot scale. We're in discussions with, a number of different companies that, strategic partners that are very interested in being able to use their flue gas from a different industrial process, whether that's cement or another manufacturing process, where they might have, 15 to 25% CO2 concentration in that flue gas stream, being able to use that to cure our products. We believe there's a clear path to being able to do that. And then there's a number of DAC companies or industrial point of capture companies that, we've had discussions with about, sequestering the CO2 that they capture. I mean, that's often one of the big challenges is you capture CO2 from a process, but then what do you do with it to permanently remove it? Underground storage of CO2 is quite expensive and challenging. So we're a great alternative to being able to permanently sequester CO2 into our products.
Okay. How do these products compare in terms of cost to cement-based concrete products?
Yeah, so today we are on a unit cost basis competitive to a cement-based product. Each location slightly different. It depends on what is the cement price, because we're basically saying we're getting rid of cement costs from the bill of materials, and we're replacing it with slag, CO2, and a slight additional amount of electricity for the temperature and air control within the chamber. But today we often see slag costs at $0 per metric ton, or even negative, where we're being paid to take raw slag before it's ground. So that creates, I think, a really interesting, economic situation where, on a unit cost basis, we can be competitive and in many situations be, lower cost in a material way than a cement-based product. And especially when you think about 3 to 5 years down the road, as cement prices continue to escalate, slag and the CarbiCrete technology become a great hedge against those cost increases, because there's a tremendous abundance of steel slag at very, very low values, and it's just being able to kind of put those pieces together. But we can be competitive today compared to a cement-based product.
Okay, and since we have the time, I think I'm just going to see if I can ask a few more questions.
Sure.
Let's see, we have, can specifiers request lunch and learns from CarbiCrete?
Yeah, so our team in the U.S. as well as in Canada has met with a number of different construction companies, architects, engineering firms. We're happy to do that, depending on location, doing that in person or virtually. So definitely you can reach out to CarbiCrete, either through the website or in contacts, after the presentation. And we'd be happy to kind of talk to you about, what your needs are, and being able to conduct that out in the field, or again, virtually.
Are going to apply the, I'll try to get this out, are going to apply to reinforced concrete? And if yes, how the pH decrease is handled? Not quite sure exactly what that means. Maybe applying to reinforced concrete, yeah.
Probably going to have to ask that whoever asked the question
retype it.
Reach out separately.
Okay.
Even if you retype it, I'm not probably the best person to answer the question about how pH decrease is handled.
Okay.
So,
okay. No problem.
The question.
And then it looks like a final question is concrete color affected by the steel slag used?
Yeah, so the materials that go into the mix impact the ultimate end color. So typical, and again, it will vary a little bit, but typical EAF slag will be slightly darker than a traditional Portland cement. So our concrete will be slightly darker than a traditional cement-based concrete. There are other slags that we use, things like ladle slag that typically have a much lighter appearance in color. Those will be much, if we were using ladle slag at a location, those would be probably more similar in color to a traditional concrete-based product. And then just because, the question about color, we have made through mix, color pavers in a variety of, kind of medium and darker colors. As well as face mix technology, which is often used in pavers, particularly on the professional pavers, where there's kind of a relatively thin top layer of a color on a let's say a normal colored base. So our technology, we've been able to demonstrate the ability to do that, and we've produced products with through mix as well. So happy to answer any questions offline about that if people are interested.
Okay, I think we'll just do one more and then we'll be done. Let's see what we have. What products can be made using this process?
Yeah, again, so we shared a picture in the presentation earlier. Maybe I'll just pop it back up there. The pictures at the top, so CMUs and different shapes of CMUs, that's a typical North American standard, but like the standard CMU in France has a different shape. We can do that. It's just a different mold in the machine. Really anything that, from a mold standpoint, like the deck blocks is a little bit more of a typical Canadian product for holding deck posts. That's something that, our customer, went ahead and just made based on a formulation they used for a different product with our technology, and had great success and very quick success with it. So, all of those different kind of paving, hardscape products are things that we're able to do. The items that are in product development listed below, so colored pavers, so we continue to work on the most economic way to make colored products. And then, these interlocking pavers, professional pavers, those are thicker. So, typically there's a little bit of development work to make sure we have the formulation correctly so that we get the full strength performance that we need for those professional thicker material products.
Okay. And it looks like we have one more question that just popped in, so I'm just going to quickly ask it. Are these products lower GWP than all other masonry products available in the market today?
Yeah, so I think that was, I covered that a little bit earlier, but we're about 20 times lower than the industry standard for CMUs, and even more, even a greater factor below a ready-mix concrete. So, we're at 11.7 versus around 230 to 270 GWP for traditional cement-based concrete. So, really significant environmental impact. And again, GWP is a measure that's captured in our third-party validated EPD that measures the CO2 content per cubic meter of concrete.
Okay, thank you so very much, Jake, for answering all those questions. I really do appreciate it. Okay, we're going to wrap it up today. I'd like to thank Jacob for his presentation, for answering our questions today, for highlighting CarbiCrete. We'd just like to thank you, and please visit the new website at newconcrete.org for more information. While you're there, please check out our resources on lower carbon concrete production and placement. And our website provides access to our sustainable concrete guides, frequently asked questions, webinar recordings, and upcoming webinars. Our next webinar will be held on March 27th, highlighting EcoSem with of news members, and we hope to see you there. Thank you again, Jacob. We really do appreciate it. Have a good day, everyone.
Great. Thanks, everyone. Take care.